Hello, in this video I'm going to show how to solve this problem involving an accelerating train with a single train car. So we have a train engine, mass big M, train car, mass little m. They're connected together by a coupling, and they're accelerating to the left, the direction the train engine is pointing. And we're going to solve a number of things about this. Okay, so I guess we're also told that there is a friction F force friction car, FFC, slowing the car down. So we're told that as well. Now let's see here. I'm going to start with part one. Draw a free body diagram of the engine and a free body diagram of the car. All right. Put the engine free body diagram over here, car free body diagram over here. As you probably suspect, there's a force of gravity, which is big mg on the engine, force of gravity 2 little mg on the car. Going upward, we have force normal engine. I'm just kind of coming up with names for these forces. Force normal car. Okie dokie. What else can I have? Well, we're told we have a force friction. Let me make it a little shorter than that. Force friction car that slows the car down. Well, what is going to pull the car forward? There will be force tension car pulling it forward. The coupling between the two, the engine and the car, is going to pull the car forward. If the coupling pulls the car forward, then there's an equal and opposite force. Force tension engine that is equal and opposite and pulls the car backward. Okay, one more force to add to the engine, and that is the frictional force pulling the engine forward. That's going to be the big one here. Force friction engine. It has to pull forward because the whole contraption needs to move forward. Okay. Okay. What is the tension in the coupling between the engine and the car? So basically, what is the magnitude of this tension? It's the same magnitude as this force, that equal and opposite force. What is that tension? What is the magnitude of those forces? We'll write the answer in terms of MMA and the frictional force. So number 2. Okay, so I'm going to look at the free body diagram of the car, and I'm going to do the sum of the forces in the x direction. If I'm going to do the sum of the forces in the x direction, I have to specify what the x direction is. So I'm going to call that the x direction. I can call left the x direction if I like. Okay. Sum of forces in the f direction. I have force tension car minus force friction car is equal to mass of the car A. That's the equation is the sum of the forces equals ma. That's Newton's law. This right here is the sum of the forces equals ma. We are looking for the tension force. We know the frictional force and the mass and the acceleration. We're told to find in terms of them. So we can just simply solve this in terms of force tension car, move the force friction to the other side. We get force friction car plus ma. That is our solution for the tension in the coupling. Okay. The part number 3 asks us, what is the magnitude of the friction force between the engine's wheels and the track? Write the answer in terms of all the other variables. Okay. So we're trying to find the frictional force of the engine. So it's pointing forward, but we're told to just find the magnitude of it, how big it is. Okay. We can do the free body diagram of the engine now. So we have force friction engine minus force tension on the engine, which is equal in magnitude of force tension car, is equal to big MA, because this is the big M corresponds to the mass of the engine. Okay, rearranging that, I get force friction engine is equal to force tension engine plus MA. But we know what force tension engine is. That is the same magnitude as force tension of the car, because of equal and opposite forces. So force friction engine is equal to force friction car plus MA plus MA, or if you want to write it more succinctly, force friction car plus M plus MA. I should also note that there is another way you could solve this problem, and that is by treating the entire train as a single object. It has friction pointing backward on it, and to accelerate it, you need to accelerate the entire mass, m plus m. So we could do it that way as well, where we say the force of the friction on the engine needs to counterbalance the friction on the car, and it needs to cause acceleration, m plus m a. Okay, so that is how you solve this problem. That it's an E, by the way, that's force friction engine is force of the friction of the car plus sum of the m's times a. Have a good time solving the other problems on this